Hello students, in this video we will discuss about the subsets and example of subsets from the chapter sets. Okay. First of all, we will discuss about the definition of subsets. Consider the sets. X is a set collection of all students in your school, and Y is another set collection of all students in your class. Okay, so you can easily say that all the students in my class is also the student in my school, right? All the student in my class is also the student of the school. That means every element of set Y must belongs to set X. Suppose you are in class 11, right? You are the student of your class. You are also the student of your school. That means you belongs to set Y as well as you belongs to set X. Okay. We note that every element of Y is also element of X. Obviously, every student in class 11 is also the student of your school. That means every element of set Y must belongs to set X. We say that Y is the subset of X. Okay, since every element of Y belongs to set X, that's why Y is the subset of X. Okay, the fact that Y is subset of X suppressed in symbol as Y subset of X. This is the symbol Y subset of X. That means every element of Y belongs to X. Okay, now we will discuss about the definition. Definition is a set A is said to be subset of a set B if every element of A is also element of B. Okay. In other word, A subset B if whenever, this one will be small a, whenever small a belongs to capital A, small a also belongs to capital B. Okay, so I will give you an example. Suppose you are considering A set as 1, 2 and B set as 1, 2, 3, 4. Okay, as you can see, this 1 belongs to B also. 2 is the element of A and 2 belongs to B also. Okay, that means every element of set A belongs to set B. That's why A is a subset of B. Okay, but if you think it in converse way, 3 belongs to B, but 3 does not belongs to A. 4 belongs to B, but 4 does not belongs to A. That's why B is not a subset of A. Okay. In this way, you have to judge which one is subset or not. Note, using this symbol, we can write the definition of subset as follows. Capital A set will be subset of capital B set if any element in capital A set is also be the element of capital B set. This notation means A will be subset of B if element A belongs to A implies element A belongs to B. Means whenever a element belongs to A subset of B implies that element have to be belongs to B. Okay. We read the above statement as A is a subset of B if A is element of set A implies that A is also an element of set B. If A is not a subset of B, we will write A not a subset of B, this notation, A not a subset of B. Okay. So let us discuss about some example. The set of rational number is a subset of the set of real number. So you will write Q is subset of R. Okay, you know this from class 9 that all the rational numbers such as minus half, half, then 1, 2, minus 2, minus 100, then minus 1000 by 3, these all are rational numbers in the form of P by Q, and all the rational numbers are real number. That's why Q is subset of R. Okay, but converse is not true, means you cannot write R is subset of Q. This is totally wrong. R is not a subset of Q. Why? Because you can take root 3 from the real number set. Root 3 is a real number, but root 3 is not a rational number. So root 3 will not belongs to Q. That means a element from real number does not belongs to the an element from real number does not belongs to the set of rational number. That's why real number is not a subset of rational number. Okay. Now let A is the set of all divisor of 56 and B is the set of all prime divisor of 56. So first of all, if you write A set in roster form, all the divisors of 56 is 1, 2, then 4, then 7, then 8. Okay, then if you divide it by 4, it will be 14, then 28, okay, then 56. This will be set A, all the divisor. Now B is all the prime divisor, so B will contain 2, 7 only. So as you can see, all the element of B belongs to set A. All the elements of B belongs to set A. That's why B will be subset of A. Done. Let A is equal to 135 and B is equal to the collection of X, where X is an odd natural number less than 6. Okay. So again convert this B in roster form. It will be odd natural numbers less than 6. That will be 1, 3 and 5. So as you can see, A and B are the collection of same element. So you can say that all the element of A belongs to set B. All the elements of A belongs to set B, that is A subset of B. Again you can say that all the elements of B contains to A, that means B is subset of A. So for two sets, if A is subset of B and B is subset of A, you can write A is equal to B. Okay. If A is subset of B and B is subset of A, then you can write A is equal to B. Look at here, A is equal to B. Now let A is equal to A, E, I, O, U, B is equal to A, B, C, D. Then look at here, here I is in A set. Okay, I is the element of A set. That means you can write I belongs to A set, but I does not belongs to B set. Okay, that means there is an element in set A which does not belongs to set B. So you can write A will be not a subset of B. Okay, similarly you can say that here is the element B in B set which does not belongs to in A set. That means you can write B belongs to set B, but B does not belong to set A. So you can write B is not a subset of A. So from this example you can say that A is not a subset of B and B is not a subset of A. Now note here, let A and B be two sets if A is subset of B. Okay, A is subset of B means all the elements of A belongs to set B. All the elements of A, suppose this is A set, these are the elements of A. A is subset of B means all the elements of A is also the element of B. Okay, that means B is the bigger collection. Okay, actually you have to draw it in this way. If this is A and A is subset of B, this one will be A set and B set will contain this A set. Okay, this B will contain this A set. That means B is the bigger collection, A is the smaller collection. So you will say A is the proper set of B and B is the superset of A. This B is superset of A and A is proper subset of B. Okay. For example, if A is the collection of 1, 2, 3 and B is the collection of 1, 2, 3, 4, then A is proper subset of B and B is superset of A. Okay. Now what is singleton set? If a set contains only one element, then that set will be singleton set. If a set has only one element, we call it as singleton set, such as second bracket A. This set contains only one element and that element is small a. Okay, so this is a singleton set. Now we will discuss about two examples. Consider the sets phi. This phi means null set. There is no element in this set. A is equal to 1, 3, B is equal to 1, 5, 9, C is equal to 1, 3, 5, 9. Write the symbol of subset and not subset between each of the following pair of sets. First of all, phi dot 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 B. Okay, what will be in this bracket? It will be this subset or not a subset sign. You have to justify the answer. Always remember that null set will be the subset for every set. Null set is a subset of every set because null set does not contain any element. Okay, that's why you can say that null set will be the subset of every set. That's why here the symbol will be subset. Okay, now A space B. Okay, look at here. 1 belongs to here, 1 belongs to here, but 3 belongs to A, 3 does not belongs to B. Okay, 3 belongs to A, but 3 does not belongs to B. That means A will be not a subset of B. Okay, now the third one, A and C. Okay, look at here. 1 belongs to A, 1 belongs to C, 3 belongs to A, 3 belongs to C, and 3 contains more element. That is 3 is the superset, right? 3 contains all the element of A. That's why C contains all the element of A. That's why A is a subset of C. Okay, now fourth one, B dot 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 C. Okay, again 1 is here in B, 1 is here in C. 5 belongs to B, 5 belongs to C. 9 belongs to B, 9 belongs to C. Okay, and C contains another 2 elements. So you can say C is the super collection, C is the bigger collection. That means C contains all the element of B, that's why B is a subset of C. Okay, in this way you have to place the proper symbol in the bracket. Now next example, let A, B, C are 3 sets. If A belongs to B, B is a subset of C. Is it true that A is subset of C? If not, give an example. The answer will be no. Why? Suppose I am considering A is a singleton set containing one element 1 and B contains single set 1, singleton set 1 and 2. Look at the B set carefully. B set contains singleton set 1 and the element 2. B contains a set singleton 1 and 2. C contains a set singleton 1, then 2, then 3. 2 and 3 are simple digits, they are not set. Okay, so as you can see, this A is belongs to B because A is equal to singleton set 1, which contained in set B, okay, which is in the set B. So you can say that A belongs to B, okay, because A set is the element in B. Okay, so A belongs to B, right? Again, if you check the relation between B and C, singleton set 1 is here, singleton set 1 is here, 2 is here, 2 is here. Okay, that means B is a subset of C. So these 3 examples satisfies these 2 conditions. But if you look at A set and C set, okay, if you look at A set and C set, okay, 1 is the element of A set, 1 is the element of A set, but 1 is not the element of B set. Singleton 1 set is the element of C set, 1 is not the element of C set. This set is the element of C. This single digit is not the element of C. So you can say that 1 belongs to A. This digit 1 belongs to A, but 1 does not belongs to C. Singleton set 1 belongs to C. That's why there is an element in A which does not belongs to C, implies A is not a subset of C. Okay, A will be not a subset of C. Okay, note that an element of a set can never be subset of itself. Okay, so here the answer will be no. Now here is a discussion about subsets of set of real number. You know, the natural number is the collection of these numbers 1, 2, 3, 4, 5 and so on. Integers are the collection of these numbers 0, 1, 2, 3, 4 and so on, again minus 1, minus 2, minus 3, minus 4 and so on. Q is the collection of all rational number in the form of P by Q, okay, which contains 5 by 7, 3 and 1 and half, minus 11 by 3, 2, 3, minus 2, minus 3 and so on. Irrational number T, okay, the set of irrational number is represented as T, which contains root 2, root 3, root 5, pi, e, this number. Okay, now we will discuss which one is a subset of another. As you can see, all the elements of natural number belongs to integer. Okay, all the numbers 1, 2, 3, 4, 5, 6 and so on belongs to integer. That's why natural number is subset of integer. Again, all the element of integer belongs to rational number. Why? Because you know that 0, 1, 2, 3, 4 and so on -1, -2, -3 and so on. These all numbers can be written as in the form of 1 by 1, 0 by 1, 2 by 1, 3 by 1, then -3 by 1, -2 by 1 in this way. That means all the integers are rational number, or rational number set contains all this element of Z. That's why integer will be subset of rational number. Again, all rational number are real number. That's why rational number, set of rational number will be subset of set of real number. Then all of irrational number is subset, all of irrational number is also a subset of real number, because all the irrational number is real number. But if you judge between natural number and irrational number, that means n and t, you know that t contains the element root 2, root 3, root 5, root 7, pi. Okay, t contains this type of element, and natural number contains 1, 2, 3, 4, 5 and so on. So no element of this n will belongs to t. Similarly, no element of this t will belong to n. So you can say that n is not a subset of t. Again, t is not a subset of n. Similarly, for irrational number and rational number, rational and irrational number both are different. Okay, no element of rational will belongs to irrational number set, or no element of irrational number sets will belong to rational number set. So you can say that q is not a subset of t. Again, t is not a subset of q. Okay, in this way you can relate the relation of subsets between the real numbers, between the sets of real numbers. Okay, so this is all for today. Just clarify all this idea of subsets in your mind. So just check this video very carefully. Thank you.